Hello, my name is David Valdés, and today I wanted to talk to you about function notation and vocabulary. But the first thing we should ask ourselves is, what is a function? Well, I've drawn a couple diagrams here to illustrate a function. The first one is this sort of machine-looking thing where I put in an input on this side and I get an output on that side. And in the middle, the function does something to the input, and the output might be the same, it might be different, it depends on the particular function. Now here's a little diagram to show what a function does in a different way. Suppose I have a set of inputs here, which in math we usually like to denote as x. You could really call it anything you want, but to stick to something familiar, we'll go with x's. We'll input x values, these are different x values, x1, x2, and x3, and we'll output y values, and these are different y values. Notice that the function takes the input and gives you an output. For x1, I put that in. I don't know what the function is, but I know I get y1 out. Okay, if I put x2 in, I get y2 out. If I put x3 in, I also get y2 out. And that's okay, but what's not okay is to get two different outputs. What's not okay is to do something like this, say that this gives me a different output, okay, for the same input. Can't do that. That does not define a function. So for every input, there is exactly one output. That's how we can define a function. Function notation usually uses the word f, although it could be denoted by any letter. So let me say the function itself is denoted by f, although it could be many other letters. And let me try to get a little bit more specific with this diagram related to my x's and y's. In this case, what I would say is that the function that I'm calling f has an input of an x value and an output of a y value. So I would say f of x is equal to y. The x, again, is the input. Whatever that turns out to be, the y value is the output. We also call these independent and dependent variables. The input is the independent variable. Independent variable. And the output is the dependent variable. Okay. It's dependent because it depends on whatever our input is. Okay? We don't get the output until we put in the input. And when we put in the input, the function does something to it to give us the output. So the output is dependent on the input. The input is the independent variable. The output is the dependent variable. So let me take a look at an example of a function using x and y and state it in this way. I could say, for example, f of x is equal to, and let's just make up something, how about x squared plus 1? And that's going to be equal to our output values. A lot of people write this the other way around. They might say y equals f of x equals x squared plus 1. Now, if you recognize this y as always equaling f of x, then you can sort of drop the y notation and just stick with the f of x notation, realizing that that is really the same thing as your outputs you're calling y in this case. So let me, now that I've defined the function, that is, I've defined the machine, this part of the machine, I've also defined what takes my x values and gives me my y values. Let me put in some x values and see what I get. This diagram may not represent the function that I'm writing here. Let me just choose an x value. Suppose x is 3. Okay? Then what I'm going to do with this is I'm going to put 3 into my function notation. And this does not say f times 3. This says f of 3, a function where the input is 3. F of 3 is how we say that. And then we put this input into every place that we see an x variable over here as we've defined the function. So I'm going to put it in right here. square it, add 1. This gives me 9 plus 1, which is 10. And 10 is therefore equal to my function of x evaluated at 3, or we could call it y. Okay, let's try another one. If I plug in f of -8, for example, then I just stick in -8 right there. Squared plus 1 equals 64 plus 1 is 65. And that's a different y value. Okay. So these are particular x values. Those are particular y values that correspond to those x values. And maybe I could give them particular numbers. I could call this one x1 and this one x2. Okay. x1, x2 as my particular inputs. That makes this y1 and y2. Okay, stay tuned for the next video where we talk about functions a little bit more. This is just a quick introduction. I want to talk about relations and domain and range and graphs and all kinds of other things. So hang out with me.